Hi, everybody. Welcome to the tutorial. Just a bit of housekeeping. So you should have gotten an email from Angela about the wireless, but here's the password, 24 Weston 24. We're going to be using a nurse location reservation that's been given to us for the whole day. And so that's going to be this EAMxx underscore tutorial is the name of the reservation request. And I'll give you more details on how we can use that when we get to the part where we're actually submitting stuff. If you don't have the E3SM repo currently somewhere in your nearest home or something like that, go ahead and clone it. This is what the command line would be for that, but you can also just go to GitHub and copy the URL. And just like PSA, remember to always update your submodules. That tends to get me almost every single time, so that you won't be hitting those kinds of errors starting right off the bat. Everything that all of the tutorial materials are actually on CFS right now. So if you go to this location on Perlmutter, which is the generic E3SM CFS directory, but underscore EAMxx tutorial 2025, then you'll find basically everything we're going to be using for this tutorial. And the start would be to use this run script. That's going to be the first thing we're going to do. And here, that's that line. So when it comes time, this is the XML change line that you would use in order to make sure you're using the EAMxx tutorial reservation. And then, of course, for just in general, a lot of what we're going to talk about is already in the docs. We'll have a docs presentation tomorrow during the EAMxx breakout session, but this is where those docs are. So there is a EAMxx docs page, which is housed with the rest of the E3SM docs. So I'm going to go ahead and start over here, just kind of with these first bits. Let me make this bigger. Yeah.
Submodule thing. I have to do the last two commands, but using init in the last command for this.
Yeah, I just go crazy because I'm just so untrusting. I'm sure there's probably a cleaner way to do this, so you don't have to do my gobbledygook. But it's like the redundancy gives me a sense of like peace in myself. But yeah, maybe it's a little overwhelming.
You can simplify it, just do the init.
I'm not doing it. The moment I touch it, it's gonna break, and then I'm gonna view Walter and be like, Walter.
Is that submodule command gonna screw things up if we've already got it installed and we haven't updated it in a while?
It shouldn't.
It's safe.
It's just
already got it checked out.
Yeah, it should be. I mean, so you should also be on the most recent master. That's going to be really important.
Yeah.
So I don't think that the most recent master there's a potential it won't even build if you don't have the submodules all updated. So I think it's kind of a 1-2 punch. Yeah, that's not written here, but Charlie makes a good point. You should also be on the latest master. So do check out master, git reset, hard raster, or git pool or something. Question? Not yet. Sorry. We were hoping to do it, but we didn't get there. Actually, Nas is going to brag about a really cool idea that he has that we'll put into place after the tutorial so that these are all available, but even in a really smooth way. My apologies. Yeah, it would be nice to be able to copy and paste them. Hopefully we'll be fine though. Okay, so I'm going to actually start with this first step, which is going to be, I'm going to copy this run template. I know you guys have to type this all in, so I apologize. But I'm going to copy it. For some reason, the script, the path I have here doesn't work. I think I messed up. Yeah, there's a dash missing. Okay. I'm just going to go here. Okay. And so if we look at that run script, it should be fairly familiar, right? So this is the run script that it's very similar to the run script that is shipped with regular E3SM, but the run script that's currently there isn't set up for PM GPU. So we put together just a couple of changes to the run script. But essentially, this run script, as it's set now, should build a job and submit a job for you on PM GPU. But there are a couple of changes that we first need to make. So if you pull that run script open, probably the most important one is down here, your code root, because everybody might have a different location that they've been storing their E3SM code root. So if you want to make that change, for example, mine is on home. Here. Okay, so for the first part of this presentation, actually, I'll go to the next slide to make that clear.
On just one.
On here,
The term.
is that good?
Yeah.
Even bigger? Sorry. So now that we've got a run script open over there and just kind of understanding what we're going to do. So for the agenda, the first half of the tutorial pre-lunch is all going to be about running and changing a standard EAMxx case. So running just out of the box vanilla EAMxx. And then the second part is going to be actually doing development in EAMxx, so adding a completely new process to EAMxx. And so my hope is that your takeaway from part one is that running a case with EAMxx stream is almost the same as running your typical E3SM run that I hope all of you have done at least once, just for a science production run. But there are some nuances that we really want to dive into, and that has a lot to do with runtime options and how we actually change the run. That is distinctly different than our typical runs with vanilla E3SM. Controlling output, and then there are a couple of new capabilities that you can do with EAMxx that we want to go into at the very end. After part one, depending on time, we might be able to just work together until about lunchtime, but then we'll have lunch. We'll break for lunch for about an hour. I think Angela already noted that theoretically, we're not supposed to be bringing food that's not from the hotel into the hotel. So I'm supposed to tell you that you have to like either eat here or eat somewhere else and then don't bring your food back. But that is the rule. So we'll break for lunch. My hope is that I'll just probably grab and go so I could be here in case people have questions. I don't know what the rest of the tutorial folks will do, but this might be a working area. And then for part two, that'll be the rest of the afternoon. And then we'll finish up with some open exercises to kind of give you an opportunity to work on the code in a way that kind of fits in the framework of what you're hoping to get from the tutorial. And we have some ideas for exercises to do, and then we'll be available to work with you depending on what you actually want to work on. So running an EAMxx case is actually essentially the same as running any case. And just like any particular case, like a coupled run or an ocean only run or an atmosphere only run, there's a comp set associated with that. And in our case, for EAMxx Scream, the comp set is F2010 Scream V1 right here at the top. But once you've decided the comp set, on like kind of the most basic level, just doing a create new case, create setup, case build, case submit. That's all you need to do as long as you specify that you want to use the F2010 Scream V1 comp set, and you'll be ready to go. And that's what you'll see if you come over to the run script that we just, changed. You'll see that at the comp set level, we're choosing an F2010 Scream V1 comp set. We are going to run on any 30 PG2 for these exercises. You're welcome to change the mesh if you want, but any 30 actually fits quite nicely in a single node on PM GPU. And it gives us a little bit something more interesting to look at. If we go down to the defining the type of run, this is just something distinctive to recognize that's particular to our case. So you see we have this run and we've put in a 4x1 and then a 1x6 days. It's important to note that since we're going to be using the GPUs, and you can run EAMxx on CPU, there's no it's not prohibited, but we're going to be running on the GPUs. This 4x1 is telling the run script that we want to designate 4 GPUs on one node for this run. So if you wanted to run on 8 GPUs, you'd need 2 nodes because Perlmutter only has 4 GPUs per node. But again, this job fits pretty nicely in a single node per person. And there's enough reservation for everybody to have a single node to themselves. So, so we're going to just do the 4x1. Otherwise, most of it's the same, except for down here at the user name list settings. So before we go to explain the user name list settings, why don't we go ahead and start running the template, this template run script. It should work right out of the box. And that's just because we know that E3SM takes forever to build. Did it not work?
I find the run script template at that location.
No, sorry. There's a dash missing. I don't know why they messed that up.
All right.
Yeah.
Tell them where we got the script. Let's so that if this is the script that is in the root of the repo.
Yep.
Couple key usually used.
So if we go to, so this is the E3SM root.
Right, but has that one been edited?
No, we haven't done a PR to update it. Apologies for that. That path doesn't work. So if you just go to the CFS E3SM, it doesn't,
No.
and try to tab complete this.
Oh, look at permissions.
Oh,
Yeah, okay, now I can.
you can? I thought I had changed the permissions properly. That would be up here at the 2025.
Aaron, what can I use for code root? It's been so long. I like,
Oh, yeah. The code root just needs to be wherever you've put the E3SM base code.
okay.
So wherever you downloaded the repo.
Yeah.
Yeah, it's typically on the home directory, but some people like to put it on Scratch, so we don't want to force everybody.
Can you change the evaluation in advance?
Is the reservation not currently set up to be the tutorial?
Advanced. It's
Yeah, it's wait. Oh, it's not there. Oh, I thought I had changed it. Yes, we do need to put that in there. Oh, that's weird. I thought I had put it in there.
because it wasn't active. So
All right.
we're gonna use it.
Yeah, this is gonna be the moment of truth, guys.
You would want to do it before the piece started.
Yes. So what I'm going to do is I'm going to put the command line into the chat. There can't. There's not a Slack channel. I can put it into a Slack channel. Yeah, Rob could make one. Okay. We're doing this on the fly, guys. It's exciting. Yeah, you'll want to do this before case submit, which could actually happen right here at the top of the user nameless stuff, right? Oh, I did put it in. No, I just did. So before case submit, right?
Yeah, right there.
Oh, no.
Thank you.
Yeah. Works. Because I've already done this. Is anybody having issues with this? Are we doing it in real time?
I got a warning. User selected machine PM GPU does not match probed machine PM CPU. Is that normal?
Did you change it? I think so.
So the first step is we just run the scripts.
Yeah, and that's mostly just because it takes forever to build E3SM. Having a built version of E3SM, like currently set up, I think it's helpful.
Does,
All I see.
was there a spot in the script that has our sort B?
I did get it.
Put our thing in there.
Oh yeah, so that I put in the WebEx chat the line, and then you'll put it at in the case dot. So in the case dot submit just before it submits, you can do the XML change. So I'll show that really quick again.
But there's not a line.
No, I thought I had put the line, but somehow that did not get updated. I did it last night, but I guess did not actually change in the thing, which is strange. So I'll give everybody like a couple minutes to kind of get that all set up. We can come around and help. So if you have issues, just raise your hand. Yeah. They're not available. I can make them available.
So where's that?
Oh, WebEx link. I think, did Angela not send the WebEx link out? Hmm.
Maybe I missed it.
Well, so if there is no WebEx link, maybe because you don't want everyone logging into WebEx. If you have a Slack, we have a Slack channel, so that'll be the better way to go. So what's the channel?
EAMxx tutorial.
Yeah.
There it is. Okay, so if you want to try to get into this Slack channel, I'll go ahead and then do the copy and paste the line from WebEx there. Yep. What's that? I don't know. We're just trying to figure out the logistics of the WebEx and stuff. And we didn't send the WebEx link out, but you probably didn't want everyone logging into WebEx. You wanted them to be. So I think it makes perfect sense. So we found Slack is the way to go. We're good. Okay, do you mind helping Jill get kind of spun up to where we are? Anybody else need assistance? Yeah. Yeah, oh, yeah, I can do that right. Oh, yeah, I can do that. No, I killed it. Because Shui suggested that I should just go ahead and add the line directly here.
But it's still doing 72 for the AC screen.
Yeah, we're not doing the 120. We can get the 128.
Where are your slides on Confluence?
So we haven't put them on Confluent yet. Actually, since people have asked enough times, I think either Conrad, Nasser, or maybe Nasser is the one that has the most access to the, or Conrad, you have access to the slides too. Do you think you could post them on the Confluence page for the tutorial? Yeah. Or you can just attach them to Slack. Yeah. So Conrad will put it on Slack. That'll make things a lot easier for people, right? Yes.
Just to be safe. That's my word.
This is the kind of feedback we're going for. So in the future, thank you, Gautam. So that when we do this again, we'll be much more polished. I appreciate everyone's patience. Now let's just go ahead and
E3SM. Yeah.
all right. I'll give it maybe just a couple more minutes. I'll walk around too.
So this will bring. Yeah. So what's the yeah, of course. Yeah.
I'll look right at this.
So
They are first.
yellow.
Have a build fail.
It's gonna take a bit of time. Okay, part one slide should be up there now. That's good. As long as it's doing something.
Oh,
I don't know.
Oh, I was doing technically cool.
Yeah.
Yeah.
The screen receiving those are all the default. I don't normally set this.
yeah, we're gonna.
For today, to work, you never have to.
No, we have 128. Well, we have 10 tracers, but we have 128 levels.
Right, but you never have to specify that. That's correct. But you have it.
Yeah. All right. How is everybody doing with are most of us building and watching this thing go on? Fingers crossed that it gets past the E3SM build off for me. All right, cool. So as I said, our goal is to build E3SM with EAMxx, to make run changes and to add and remove things, output streams, right? And so this is a fun schematic. The goal is to start really confused, but then be giving awesome EAMxx presentations with all the work we've done. And so that starts with just runtime options themselves. And so this is kind of the first big difference that you'll see when you're interfacing with EAMxx during just a typical runtime. So many of you are probably familiar with, you're probably all familiar with Namelist in general. Every component has them. So this would be an example of a very complicated name list for, very complicated name list parameter, name list for the atmosphere model. And what we've done in EAMxx is we've dropped name lists for YAML files, so YAML parameter lists. And so something that looks as complicated as this now becomes a YAML file, just like this. And so there's a couple of benefits to that. Well, first, I'll say that one main reason why we did this is that C++ doesn't have a native nameless parser, so we've had to create our own. But that really actually provided us with an excellent opportunity to think about how do we really want to have the users interfacing with the code itself. And one of my bugaboos has always been that I find these very hard to read. And they're also kind of rife and prone for possible errors because you can put the same name list option more than once. And there's no way that you're going to get an error when you run it. And you might get one or the other option that you put in. And if the name list is complicated enough, you might not catch your error. But with a YAML file like this, first off, it's human readable, which is super useful. It also allows us to put a lot of guardrails in. about what, if you have a parameter more than once, or even making it very difficult for you to set a parameter more than once. And that's the next thing I'm going to talk about.
And the comments? Looks like everything there.
You can, and the comments are just like Python, they're just a hash, and then you just put a comment. So yeah, you can also put comments in a YAML file, which is super useful. So never mind that this is very small type and it's very difficult to read. That's more of just a big schematic of what the file looks like with a YAML. But this is just maybe jumping down to one example. And so on the left-hand side, this is what it might look like in your run script to create a YAML name, or to create a nameless file for an EAM run, so like an E3SM v3 type run, for example. And I've purposely put the same category twice to show that this is perfectly valid. It may be unclear to you which one of these two values you'd actually get. Would you get the 6 or the 12, right? What this actually looks like now is this new tool that we call is atmosphere query and atmosphere change. So those are written here, atmosphere change and atmosphere query. And they mimic the familiar XML change and XML query. So they do the exact same thing, essentially. So when you issue an atmosphere change command, that will update the nameless parameter list that's for the runtime options to now have that particular value for that category. If you try to set a nameless value that doesn't exist or is invalid, then you'll get an error, just like an XML change. If you're curious to what your values will be, then atmosphere query serves the same purpose. Another important, oh yes, go for it, Rob.
If I did edit the name list, it did something dumb, like it's the same thing, so they get it there.
At runtime? So actually, I'll give you two answers. One, manually editing the name list is no longer allowed, right? Oh yeah, I have to repeat the question. So Rob's question was, if I manually edit the name list and do something like this left-hand example, what will happen? So the two answers are, one, and probably the most important, is you no longer can edit the name list manually. So you can open the name list and look at it if you'd like to, but any edits to that will automatically get overwritten at the case.submit step, because that's part of now the build NML will actually read in all the atmosphere change commands that you had already issued and update the name list at that point. So it takes a default name list and then updates it. So if you make a change in the name list, it's not going to be reflected. It has to be done through atmosphere change and atmosphere query, not to change it, but just to see what it is. So in one way, you can't do that. Now, if you somehow were able to force it, I'm unclear. I mean, maybe Luca could tell.
I don't know, maybe Jim remembers, to have like a impact some parameters to allow that, but I don't want to specialize that, and I don't know if it still works. We probably will do that. And also to like shuttle down also the YAML files that are overwritten, so don't edit screens.
Yeah, when we get to the point where we have a run case, we'll look at that. But yeah, pretty much it has all the layers of protection that XML change is supposed to provide as well. So you really need to be using the tools. And one great thing about that is it really kind of stops you from making one of these errors that could really trip you up overall, right? So you kind of have to do things exactly as they are valid, for example. If you could go to the case scripts directory, then this step we're going to go through how to use atmosphere query and atmosphere change to change our runtime options. And actually, if you're building, you can kind of follow along if you open a new window and log in, because your case scripts directory should actually exist already, even if you're still just building, which is what I would do, actually. Maybe not. I'm already taxing this thing. All right. But I don't really care if I build and run, so I'm going to just kill this. Yeah, but I think that the internet keeps slowing down a little bit on me because it's doing so much. I don't know why, but. Okay. So if you're in the case scripts directory, then the first thing we're going to do is just kind of to get our bearings. If you do atmosphere query -help -help, this is basically what you'll see.
I will make that false. Maybe it's not.
That's a good idea. Okay. So we see something like that. Right? And what this essentially is, it's a help. It essentially just gives you an example of what Atmosphere Query can do. So Atmosphere Query, like XML Query, is meant to allow you to understand what's going on in your runtime options without having to open the file where they're currently stored. Similarly, you can use Atmosphere Change to change those runtime options. So I'll do Atmosphere Change -help -help. You see something like this. So some important takeaways from Atmosphere Change. So reset is actually very helpful. You can find yourself getting down in a rabbit hole of changing your atmosphere changes, and then you may want to like back off a little bit. And it's not always clear how to do that. Reset will just clear all of the atmosphere change commands you've done so far. If you're doing a run script, you typically don't have to do this, but if you're kind of changing runtime options on the fly in the case scripts directory, this can be super helpful. I guess we don't use all anymore. And then the buffer only will actually just buffer the changes, but not actually apply them right away. So that's another helpful tool to have for your atmosphere change.
Probably will never need to use buffer only. It's mostly for test mods.
Yeah. And the reason why is because I think it's the order in which the atmosphere, the name list is built.
Yeah, so by the time test mods are applied, the case script has not been populated with ATM change, so it can't really run it. Buffer only stores it in some XML variable for later use.
It does clean up your terminal if you've got a lot of ATM commands in row, because it'll rebuild a bunch of times necessary.
And Walter is saying that it can be useful as a power user to clean up your terminal if you have a lot of them. So feel free to experiment, but you won't have to do it necessarily. So as you can see, there's some examples here. There's this important, and I even made this mistake in the slides. Colon is really important to separate variables or to separate fields in the name list. So I'm actually going to do something just to give you kind of a peek behind the curtain, as it were, like Wizard of Oz. We can look at the name list, but you cannot edit this successfully in the way that if you make any changes to this name list, they will not be reflected in your run. This file will get overwritten. But what you're essentially doing is changing all of these different options. And I only want to open this in order to illustrate, not that I'm super happy and giving a thumbs up, to illustrate that they're just like any YAML, there are fields that then have sublists. So we have lists with sublists, and atmosphere change will allow you to basically dive deep into all of these different layers of a particular parameter list section. And that's what the double colons are meant for. So for example, if I just query what my Mac arrow mic, I'm trying to read this very small because I don't want to mess it up. Arrow mic, I think that's it, right? With some /@ in there, that was definitely not intentional. Num of subcycles. I'm going to delete that over here. White confusion. Note the number of the double colon. What it's going to do now is go through that file and query where it finds this particular arrangement. And so there's a Mac arrow mic section, and in that section there's a number of subcycles, and that's currently 12. Right? So now what that means is that in my simulation, whatever the Mac arrow mic group of processes will subcycle 12 times per time step. That's what number of subcycles represents. And so I can change that by simply doing a similar command, atmosphere change. Yeah.
Maybe before changing, like show to illustrate the need for the column, just do the same thing with number of cycles without Mac arrow mic.
Good point. So yeah, so if I don't put in the Mac arrow mic and I just do number of subcycles,
that parameter doesn't exist.
It doesn't exist, right? And so I'm going back here to the actual raw name list.
I mean, just why?
Where's my, oh, I misspelled that.
We did num instead of number.
Yes, number.
Ah, see? There you go. So it does exist. It just exists everywhere. And that's because number of subcycles is a default setting for any atmospheric process. So anything you want to do, you might want to subcycle, right? And so it's going to list all of the possible options that you could do. So you could do it in home if you want to. Not that we say you have to, but you can do it in home or in shock or spa by themselves or combined. And so if you do an atmosphere change number of subcycles, it's not clear which one you want to change. And so you do have to specify. And this is actually a really important aspect of atmosphere query, is that it helps you understand what pathway you might have to make in order to change explicitly what you want. So actually, you'll also note here that there's kind of like ever deepening layers. So just a little bit of understanding kind of another aspect of EAMxx that's illustrated here. I keep wanting to go to the screen, but I can't. So in EAMxx, all of our physics processes are arranged at runtime. So they're not hard-coded. So anybody who's familiar with the Fortran version of EAM knows we have TFIS AC, TFIS BC, and in those we have hard-coded that like deep convection comes first, shallow convection comes second. There's some ways to turn those off and on, but there's no way to reorder them at runtime. In EAMxx, because we're using C++ and object-oriented programming, every process is just some instance of an object. And as far as the driver of the code is concerned, those processes are kind of interchangeable. And so what we do is we can arrange all of the physics or the dynamics that we're running into specific groupings, and then we can move the order of those groupings or specify that we want a certain aspect of our run to apply to all of that grouping. So in this particular example, there's this Mac arrow mic, which you can see actually has a number of subcycles associated with quite a few of the processes. And that's because Mac arrow mic is actually a group that includes turbulent mountain stress, shock, our cloud fraction calculation, SPA, which is the simple prescribed aerosol, and P3, which is our microphysics. And so by setting the number of subcycles to 12 here, we know that we will cycle through all of these processes together 12 times per time step. So you have granular control over a single process, but we also can group processes together so we can treat them as sort of their own single object that we can do things with, like subcycle.
What does Mac arrow mix mean?
What does Mac arrow mix? Macrophysics, aerosols, microphysics. So it's a cute name. You can actually make the name whatever you want, but that's the name we went with. And I think that's legacy from also the Fortran version. We have Mac Mic, something like that. The Fortran version, the Namelist that I had back there. Cloud Mac Mic, no steps or something like that. So it's just to kind of have some continuity there. So was everybody able to so we've done that. Let's actually make the change just for example's sake. So we know it's going to be just Mac arrow mix number of subcycles. And so we can make that 6, for example, if we want to. It's trying to be very clear here that any manual edits to your namelist are going to be lost. It's going to tell you that every time as a big reminder, don't change the namelist manually. But now if we were to atmosphere query again, oh wait, so I actually have to ask it for the Mac Mic one. Otherwise, it's going to show you the options. It's now been changed to 6, right? So it used to be 12. So it's really kind of that straightforward. And now if you want, you can go ahead and case.submit. And now we'll do, all right, mine won't submit because I didn't build properly. So, but if you were to do, if you were to just do a submit, then it would submit it again. It'll be the exact same run, but now you'll only be cycling the macrophysics, aerosols, and microphysics 6 times per time step rather than 12 times per time step. Yes, question?
You said that subcycle.
Yeah.
I mean, when you try that level and then you're supposed to be conscious.
Yes. So let me go into the name list and show you. So Mac arrow mic. This is Mac arrow mic. It's setup. And this is going to be really in the weeds. So forgive if anybody is checking out right now, that's fine. But I think it's a good question. So it would be interesting to dive into that. Yeah. So the question was, when I change Mac arrow MIC number of subcycles to 6, is it changing it for all of those processes? Like what exactly is happening? Because that is a little bit opaque. So what is actually, what happens is under the hood in the code, this group that we've called Mac arrow MIC is treated like a single object, which will be called at runtime. So the driver, the code itself will say, I'm going to call Mac arrow MIC now. And I don't know what that is, but I do know it's a thing and I need to call it 6 times for this one run step. So I need to call it 6 times in sequence because that's what I've specified. And then inside Mac arrow MIC, it has already been defined that that includes all of these processes. So TMS, shock, cloud fraction, P3, et cetera. And so then once the call sequence goes to Mac arrow MIC, then the next layer down is to just go through all of the processes that have been embedded in that particular group as defined. So you could actually do something pretty creative. You could do Mac arrow MIC subcycle 6 times, but also subcycle microphysics an extra 2 times. And what that will do is you'll have 12 subcycles of the microphysics and 6 of everything else. Does that make sense? So you actually get a lot of, you have if you want to do this, if you really have a compelling reason to, so it's very much in the weeds and power user thing, but you have the liberty to really dial in what you want to do. And it's worth noting that what's happening is the 6 times is it's going to call everything in sequence once, and then it's going to go back to the beginning of the sequence and call it again, and it's going to do that. That's what it means to cycle through. So if you subcycled the microphysics, it would call everything and hit microphysics, then it would call it twice and then finish out. And then it would go back through again and call it twice and then finish out. So you have this kind of granular control.
So the answer is no.
I like robust answers. Yeah. Yes.
Okay. I'm very confused about something. Where is the YAML file? This is an XML.
Yes. Okay. Good point. Unfortunately, because I keep filling out my build, but if you guys go to the run scripts directory,
You'll have it.
or the run directory, I'll have it too.
Because it runs also at case setup built in.
Oh, okay. Good, good. So if I go to the run directory, there's a data subdirectory. And you'll see scream input.yaml is in there. This file gets created at case.submit. So again, if you update this file, it will go away the next time you submit the run. So everything has to be done through atmosphere change.
It's created every time build NML runs.
Yeah.
So 4 times during the sequence will be created.
So actually, it's a good point that Rob brings up. If we actually look at this file, it's a lot easier to read. So what you're looking at here is embedded. We always have to tell it all the processes that are going to run. And at the very top level, we define 4 of them. It's importing from the surface. It's running the dynamics. It's running all of the physics, and it's going to export everything back out to the component coupler. But if we go one layer deeper, we see that there's this physics group. And what do we define physics to be? Well, it's this Mac arrow MIC and this radiation. So those are now just 2 processes. And then if we go even deeper and we look at what Mac arrow MIC is, well, that's actually all of those processes I just said. And then if we go deeper again, we can look at each one of those processes and look at what the specifications are for that. So you can see that cloud fraction will only cycle once, but Mac arrow MIC will cycle 6 times. So ultimately, we'll have cloud fraction cycle 6 times too, because it's embedded in this group. So there is this nesting of processes. And you can also make the same group twice and give it 2 separate names. If you wanted to call a little bit of physics and then call dynamics and then call physics again, you could do something like that before you do import and export. Again, there's just a lot of flexibility in the code because it's really seeing the code as these sort of abstract objects of processes, and you're defining what you want to do with that. Of course, within the reason of scientifically valid and it'll actually work.
So that data directory also has output file.yaml.
Yep, we're getting to that next.
Oh, okay.
So thank you, Rob. So Ryan was asking about the other file, which is this output.yaml file. There's also a nameless file in there. That's Home's nameless file. So Home still has a nameless, so that has to be created. Luca?
Before maybe moving to output, like I would show all the ways that you can leverage ATM query to look at it. There's a couple of other ways that you can use ATM query and ATM change. Like the -- grep is useful. If you don't remember exactly the name of a parameter, you just put -- grep and bunch of piece of the name like sub, and it will find everything that has that string in it. So sometimes I use it when I don't remember exactly the full name of a parameter, and it just helps. Just a few things. If you can also ask for a known leaf node of this tree, and it will print recursively the whole tree from their end. So you can do ATM query mac aramid, and it will print every single option in there. What else?
Which is huge.
The value systems.
So it's just a few ways that you can, and then the same options as you say that apply to XML change. If you don't know the type of a parameter, you can ask -- type. You can do -- valid values. If the XML is written in such a way that only a set of values are allowed, it will print those. -- full will print every single detail about that parameter. So those are similar options to XML change. Yeah, so we have to do maybe a better job in listing, the type and the docs and the valid values for certain parameters. If they're listed in the XML defaults, it will appear here.
And so, yes.
Really nice, all the features of ATM query. So I'm going to ask Mark Peterson, is Omega going to use the same thing, or is Omega going to make their own query thing?
Shouldn't call it.
Hopefully Ocean Query.
We have not considered that. We're using YAML file format for the input, and we're just changing the YAML file right now, but we're only at the standalone stage. We will couple in a year, so we'll have to make those.
I would hope that we don't end up with an ATM query and an Ocean query that is very similar but different. And
You mean, so are you referring to like these options having a grep feature so that it's pretty universal?
query, the E3SM query eventually is all about YAML based.
Generalize, but that requires there's a few things that are baked in assumptions about how we're implementing. So I don't know, we can talk with the other components and see if there's a way to write a single tool. Be okay with it. But
Anyway, just a comment. We need to discuss.
All right.
one last thing I wanted to say for ATM change, if you want to change all the parameters with a particular name, like all the number of subcycles set them to 1, you can do ATM change, uppercase all, column, the name. That will look for every single entry called like that. It's kind of all, it's kind of like a wild card.
Is it -- all?
No, it's like uppercase all, column. I think that's what it is. No, attach to all, column, and then the name of the parameter. The -- all was different, but this should work.
Let's see if it works. Nah, it doesn't like it.
What is the syntax, Jim? 80, maybe it's 80, not all.
We're setting them up for a really exciting time.
I mean, some methods are fixed. You gotta be aware of the other effect.
Oh, yeah.
It does.
Does that work? No.
What's the purpose of having separate XML change and ATM change?
I mean, it's the same reason why we have XML and user NL, right? One are runtime options, the other are general configuration options.
Well, no, the purpose of XML query and change was to provide an interface to editing XML. That's all. So if you're also editing XML.
Our main entry point are YAML files, but we found that XMLs are better to enforce some metadata. They're a little easier to attach metadata to each node, valid values, documentation, all of that.
So I guess is the answer. So
What's the master file? The master file is the XML file that generates the YAML.
Right. So it's not, we don't even need to put it in the case where it's the XML, to be honest, but
I think the question is, why are we not? So I think the answer is that Seam owns XML.
Some changes the things C knows about, right? If ATM changes, that's X knows about. Or like, what would be the username list on their components, right? So there's no anything on the username list for you. It's all by run. Right, and it is true that we created XML change because editing XML by hand is very error. Because you have to get all the tags perfect, bracket perfect. So it is good to have a shell script interface like that. But Chris is right that we could have a tool for every model.
So correct me if I'm wrong, Jim, if we wanted to make any adjustments to XML change, we would have to go through the Seam workflow and continuous integration. So I think ultimately we realized that it would have been a very slow process to get XML change to control our files. But I guess there's still the option.
Now that you're mature.
Now that we're mature, we can revisit this question.
I think it will be wrong. It's an inversion of abstraction. Seam should not be aware of what's the option of each component. Seam just knows that there are components. It shouldn't know that len parameter XYZ can have these values like fine.
Yes.
It's an inversion of abstraction.
It requires some more thought, but
Yeah. But I mean, I think
do
that
that later.
doubling back this question of whether or not, if we start going towards controlling our name lists with a tool like this, atmosphere, ocean, land, if we can, eventually unify them so that it's one tool, that's something we can think about long-term for sure. And making adjustments. Does anybody else have any other questions on this aspect? Yes, Chi.
Not for this one, but the one you mentioned very quickly, that Mac thing.
Mac Arrow Mick.
Yeah.
It's a great name.
What about twice? Where did you find that? Looking at the YAML file, it gives twice.
Where did I find that it's actually going to get called twice?
Right.
That is a good question. I can see the confusion. So Scream. So the question from Chi, just in case it didn't get picked up by the microphone, is we've changed the number of subcycles of Mac Arrow Mick to 6 or 2 or something. And how do we see that in the YAML file? So the YAML file is not a recipe to go from top to bottom. It is its own parameter list, which will be read in pieces depending on what part of the code cares about that piece. And so what you actually see in the Mac Arrow Mick, if you go to the subgroup, which is here, what it is, what it has inside of it, you'll see the number of subcycles is listed as 6. This will communicate to call this 6 times. So it's not going to be listed 6 times in the file, because the file is not a recipe in that way. It's literally just a parameter list, and then it allows the code to query for specific parameters. And I'll note that a lot of parameters are default. So number of subcycles will default to 1. It will always be present because the code's always looking for that. If you don't specify anything other than 1, it will default to 1. I'll also add that for our comp sets and just for the code in general, it has been built so that it will work. So for example, Mac Arrow Mick needs to ensure that we have a 5-minute time step for that section. So no matter whatever grid you run, it will make sure that because of the time step that it sets the default Mac Arrow Mick to be at least high enough to get a 5-minute time step. So there are some under the hood things happening, but that's really just based on, the domain scientist saying this is invalid unless this is at least the default. And so that's been built in there. So after the fact, you can change it if you want to, but you'll see that the defaults don't always come out to be 1, for example, but that's because there's this other aspect to it, which is just trying to make sure that the science will actually go. Yes.
So the graph is really cool, like the ATM query graph. So if I do a graph number like you did earlier, so it lists atmosphere processes, atmosphere underscore processes, carbon physics. How come ATM query then you can just omit those 2?
These 2? Oh, because it's going to find if there's less than 1 instance, if there's only 1 instance, once you do Mac Arrow Mick, it will look for the specific Mac Arrow Mick one. Or if you did P3, for example.
Okay. Yeah, so the rule is you gotta use as many, section specifier as it takes to make it uniquely.
Okay.
Yeah.
If there's only 1 number of subcycle, you don't need to specify any scope resolution, let's call Or if you want to change all of them, you use the keyword any, and it will just pick any single entry that has that name and will change it. Like for one thing, one parameter for which the any is very useful is like, I want to disable every post condition checked, which I think that after the end of an atmosphere process can be run to check for the consistency of some field, or some blah, blah, blah. And you're like, no, everything is fine. I just want to see how performant we are. Just disable those checks. So you want, instead of issuing 25 APM changes, you just issue one and it will change all of those to false. And that's pretty much the only use case that's why I introduced it to people like, oh, we don't want to do it for everything. But yeah, bottom line, back to the question, like use as many scope resolution names as it takes to make, and if it's not unique still, it will tell you, like it will error out and say, hey, these are all the matches that I found. Please be more specific. Thank you.
Any more questions? Yes.
Oh, in that section, so if you down, maybe also have number of subcycle, that one always take value of one or can also be changed.
That can be changed. That's what I was explaining earlier. So if you wanted to do 6 for everything, but you only wanted P3 to be 12 for some reason, you wanted to like double up P3 in the middle of the full run.
So is that, for example, on top of the.
Yes, it's multiplicative. Yeah. Yeah, because the simplest way to think about it is that it's going to go like hierarchically. So Mac arrow mic is going to happen 6 times, and then it's going to go into the Mac arrow mic and ask like, what does that mean? So if you then specify you want 2 subcycles of P3 in that, that'll be embedded in a sweep of 6 of those. So then it's multiplicative. There is also a super cycling feature, which we use for radiation. So let's say you actually wanted P3 to take a pause. So you wanted 6, but you actually wanted P3 only 3 times. You could presumably super cycle it so that every other step.
Hard coded only for our.
Oh, it's only hard. I thought we had put it in. Oh, never mind.
Internally.
Oh, I thought we had changed it to be no. All right, never mind.
For other processes, maybe in the future we can add it as a feature, super cycles. But it's currently only an RT and GP feature.
Okay, never mind. I take that back then.
And also interesting, the one you do any number of subcycle, you just equal to either apply to this one and this name.
I haven't built this again. So I have to go back and do build NML. So this is the old one. So if I'd have to go here and do case.setup.
Yeah, do anyone.
No, because I didn't.
Should be up to date. Build NML regenerates that file. So, and build NML runs when you do ATM change.
Yes, but I didn't do. Oh, it does?
Yes.
There you go. Now they're all 2.
Which, if you do any, be careful because then they will multiply, right? So, Mac arrow make runs twice, and each time it runs twice. Physics runs twice, so yeah, that's why there's granularity.
Yeah, for the simulation, it may not be intended just to see how.
Yeah.
Peter, you had a comment?
Yeah, I just wanted to say, since there's a lot of confusion about like change the number of Mac arrow mic, and then you change the number of say P3. So let's suppose Mac arrow mic was 2, and I want to change P3 to 3. So it'd be Mac arrow mic, Mac arrow mic, right? So it's like as the microphysics is within the loop, it gets called in sequence. Right, that's within science.
Yeah. So the way I look at processes like boxes, right? And you execute the box once, and then what the box does is like from the outside, I don't care, but then you open the box, you'll see that there's 3 more boxes inside. So running the box, you run 1, and maybe you. So it's next. What's it called?
It's a nested loop.
Results.
Yeah, you can also think of it as like a for loop. It's a nested. Think of it like a nested for loop, right? With a 1 to 6, and then inside there's a 1 to 2. So that one will ultimately get called 12 times. Any other questions? So we're only scratching the surface of all the options, but of course we only have so much time in the tutorial. But I would encourage you, if you're curious about something specific, to reach out to us because we're happy to illustrate a specific process or how something works. And any if you have a functionality you're kind of hoping was in there, reach out to us. And you can also just explore by doing things like looking at this file or doing atmosphere query and kind of jumping around in there. Yes.
The defaults can also contain XML variables from scene. I don't know if we mentioned that. But
Oh, yes, they can. That's right.
yeah, so build ML would resolve scene variables to the correct value depending on concept, whatever. For instance, the input files, the defaults are specified with in-block loop or whatever it's called. You can have things containing like stop and or stop option, something like that.
Yeah, so it's not, so you see here, for example, that the SPA data file is pointing to the CFS directory. That's not in, we don't have the CFS directory hard-coded in the defaults. What we do have hard-coded in the defaults is in loc root / just like you would for all of the other aspects of the components, right? Where they need to look up their input files or forcing or something like that. So you can use, you can set seam XML variables in your files themselves, and then it will query that for you. Like REST-N.
And if you run an XML change after a few ATM changes, you're like, oh, I forgot to change the grid, for instance, or something. They will still be kept into account because every time build.ml runs, it starts from the default and applies all the XML changes first, and then all your ATM changes. So you don't have to do all XML changes first and then ATM changes second. You can mix and match. Of course, your script will look terrible if you do one. Do all the XML first and then the ATM, but you don't have to. So if you accidentally forgot one, you can do it. You can do an XML change and then build an ML will recognize it next time.
I saw some constants in the YAML file that looked like they were universal constants, like the mixing ratio of nitrogen. And I'm wondering if there's is there a file like a shared constants file that E3SM has where you have gravity equals 9.8? And is there a distinction between what goes in there and what's going into your YAML? And what is that? What is the boundary?
So the question from Charlie was whether or not there exists like a physics constant file that's actually in the code base, not in this default, that has things like gravity, the radius of Earth, etc., versus these hard-coded or default values here. And what's the distinction between the two? So the answer is yes. And in part two, Nasser is going to, at least he's going to talk about adding a process. And so we're going to use a couple of those constants in the process that we're going to add. So you'll see that file directly and see the usage of those. In terms of the ones that are put in here, these are the parameters that only make sense with respect to a specific process. So if something is in fact universal, then it belongs in the physics constants. But this is where the domain scientist or the model developer is able to put things that, because we don't want to fill physics constants with just a bunch of stuff. And then we have like a parameter, like a process that we used 10 years ago. We still have all the parameters for it, but we don't use it anymore. No one touches those. We wanted physics constants to literally be, these are the universal constants that we want to maintain. And then here in this parameter list location, that's where we can maintain any of the parameters that go directly into the processes themselves. And also I'll note, we can't change the physics constants. So you can't change gravity at runtime. These are constants we would want to be able to change at runtime, especially when we're doing tuning. So it's important that they be removed and be given to the run as a runtime option. So maybe a better way to say that is the stuff in the physics constants really is like static physical constants that shouldn't be changed versus parameters that can be runtime options.
These are the tuning parameters.
Yeah.
One observation, like the physics constants that Aaron mentioned are still EAMxx, but there's some talk ongoing about how can we make sure that different components use the same constants. Rob probably has something to say about this.
Yeah, Charlie is asking about is the radiation parameters that we have. And those are actually what you give radiation as constants for.
Are you talking about the active gases? Is that what you were saying?
I think that's
That was the one that I saw.
Oh, sorry. I thought you were talking about the ones down here that were set to
concentrations for radiation.
Well, it just looks like if you change the fraction of nitrogen, you've got to change a bunch of other stuff elsewhere, but I understand the radiation code needs it. So I got the answer I wanted. There is a universal constants file
Yes.
somewhere else.
Yes.
It's not that. Okay.
And actually, I think these active gases, that this is defined. Those active gases do point to that file because that radiation needed to actually be able to look something up in a simple place. But the radiation is kind of unique. We had to do a lot of adjustment to get the radiation to work the way it needs to. And it's not exactly all our code, since it's the RTMGP code, which is a submodule. So we had to work around a lot for radiation. So radiation's nameless might be the more confusing of them all because of that, but
Yeah, these could potentially be time varying too, so the treatment of those can be specified somewhere here, not fixed in the code.
great. I love questions. Are there, yeah.
Would it be possible to change the physics timestamp?
So the question is, can we change the physics time steps directly? So the way, without changing the dynamics time step, I think is what you're saying. So the way you would have to do that would be, so you'll see here physics is also its own group. That has a number of subcycles associated with it. You could change it there. Ultimately, of course, you can change the coupling time step. That changes the time step for the whole atmosphere. That's typically how we change the physics time step, because the dynamics time step is calculated based on that time step. So if I were to change physics time step, that's the time step I would change and let the dynamics figure itself out rather than subcycling the physics.
The answer is that coupling time steps are exactly the same as what we give
Yeah.
Nothing special about it. One must with these. We're happy about it.
But the dynamics concept is not fully set. You can't adjust the changes. But that's expect the dynamics to it.
But doesn't the dynamics back out its time step based on a need for, does that sets the nameless?
Specify a couple of parameters for dynamics like BT, remap, factor, and BT tracer factor, something like that. Which, if you're interested, you can go and ask. Hold what if you want to really change it, or otherwise it's just the details are. If you want to change the atmosphere time step, as you said, it's an XML change, YAML couple. But it is true that technically you could subcycle physics, right? If you wanted to change that number to 2, and you will run physics with short time step. I don't know exactly what that will do with a couple of dynamics. I wouldn't do it.
I think it would be.
I think it will be buggy, but
I think scientifically it might not be what you want to do, because you'll literally run physics twice before you all the way through, and then again, and then you'll run the surface exporting and importing the dynamics. So it's probably not what you're after. You're probably after the coupling time step, which just changes the whole atmosphere step.
And those again, just to be clear, those are handled like how E3SM. Nothing happens to these things.
Yeah, thank you for the clarification. Yeah. Mm-hmm.
Not possible for the EAMxx to fix all of it. What?
So sorry, so I'll try to repeat your question. So you're asking, does it mean that EAMxx has no control over the rest of the model's time step? Is that what?
Whether it is possible for just to fix all of other suppose that I only want to change the step. Right? I don't want to change anything else.
So if you want to change just the time step from microphysics, and you want the atmosphere to run at another time step, then the way, when you say components, you mean of the atmosphere. I think the only way to do that would be to figure out the appropriate number of subcycles specification that accomplishes the goal that you're after. But yeah, sorry, go for it, Peter.
I was just going to say that the only way that you can change the time step of, say, microphysics or something is by making it multiple of the rest of the model, right? If it was like 1.5 microphysics steps per physics step, that would, right? And so I know that in the Fortran version, there was like T time and it got a little confusing. We tried to make it less confusing by only having the option of specifying multiplicity. This is what is it that we talked a lot about number of subcycles. Yeah. So you can definitely change the time step of absolutely anything.
And the way you do that is through this number of subcycles.
First, you figure out what's time step for the whole atmosphere, and then you backtrack how many subcycles you need for that.
So by any 30 by default, it's 1800 seconds. And so you back it out from there. Any other questions? Cool. So now we're going to jump into looking at, as Rob precluded, the output. So you'll also notice that in that, /run. So if we go to run, there should be an output file. No, sorry, it's got to be in data. It's output file.yaml, right? So you can go ahead and open that up. I'm actually going to focus on the slides first, and then I'll navigate with you just to kind of give you a baseline and then see where we went with EAMxx. So when it came to output in EAM, it was a nameless option. Those are highlighted here in the pink, the green, the yellow, and there's a reason why I've highlighted them this way. And essentially, you had to just specify all this important information about each output stream. Many of you are familiar with the Finkel setup, where you had like Finkel 1, 2, and 3, and that resulted in like a .h1 or a .h2 or a .h3 output file on the back end. So again, because we were switching from nameless to YAML, we had a really great opportunity to revisit how we handle output files and figure out a cleaner way to do this that's maybe a little more human readable. So I only put this up there to illustrate that this nameless, unless you are like an expert, for those of you who've seen the matrix, you've seen enough dots and lines that you can actually tell what you're looking at. If you look at a nameless long enough, you can read this. But for a new user, there's a lot to parse here. It's not even clear to a new user which of these fields they need to be looking at if they want to be changing their output. So in order to address that, we also use output YAML file. We use YAML files to specify all of the parameters for a specific output stream. And the first important thing I want to note is Finkel is gone. Now you specify a set of YAML files you want to use to control output, and each YAML file controls an output stream. So one instance of output. So if you want instantaneous temperature, but you want average water vapor, then you have two different files, each one specifying those particular parameters, and then you point to that, and then it will basically set up two different output streams and make sure that they follow what you were looking for. And so this is an example of what that would look like. So Finkel there, Finkel 1 and 2 is specifying I want these two files in the regular name list, but in the control, the screen input.yaml, so this is something you'll also do with atmosphere change and we'll do in a second. You specify the set of output YAML files you want to use, and here I'm specifying two. So I've got my first output file and my second. These do not have to have any name. They're your names. Like you just point to a YAML file with whatever name you want. Another benefit of this is if you have like a set of outputs that you want to collaborate on, you can just share those files, put them in like a local directory that everyone has access to, and everyone can use the same YAML files. You know that everyone's doing the same kinds of output without having to worry about passing around a name list that's being changed. That's the file and that's the kind of output I want. So the yellow there points out exactly how we specify this. This is the only thing that happens in the runtime parameter list for EAMxx, the thing that we've just been looking at. Then we actually have to create those files. So this is an example of what those two files might look like. Super simple. They can be much more complicated, but for the sake of being able to just focus in on the main parts, this is what they would look like. If you open that YAML file that was put into the run/data directory, you'll see something similar to this. So you'll note we have to specify what kind of averaging type we want. Before we had to list in the appropriate order, A for average, I for instantaneous, X for max. Here, all we have to do is use keywords. And so we specify an averaging type, instance, or max in this case. Again, we have these nested parameter lists. So we need to know the set of fields, and you're going to go into a lot more detail on why we use this terminology fields in part 2, where we're adding a process. Fields represents variables. So you have fields, you have the grid that those fields are on. So in this case, we're running on physics PG2. And then you have a list of the field names. So in this case, we're going to be doing QView, QC, and QI. So that's vapor, liquid cloud, and ice cloud. So that's been listed in the blue here. And again, you can see that restated here in their second file. Max snapshots per file is exactly what it sounds like. It's literally just how many snapshots I'll store in a file before I open a new file. So it just gives you that kind of control. File name prefix, this is really important. this is going to be that whole prefix that comes before you get your dot, whatever the sort of boilerplate is, .nc. It's really important that those all be different, because obviously you can imagine that you're going to run into issues if the prefixes are all the same and it's trying to open the same file for different instances. Now, note that the file names will, by default, also include the averaging type, so max or instant. So you could, as a power user, have the same prefix, but no, you're using different. But for safety purposes, I would just recommend always using a prefix that's unique so that you know exactly what you're doing.
Nasser had a bug once where he used a different, he wanted to use different averaging type, but copy paste went the wrong way. So it was, maybe it wasn't, someone had like, oh, I can use the same prefix because I'm going to use two different average types. So I forgot to change it, and then there was some weird error at runtime. We're in the process of adding more safety checks, but that's why.
Yeah, but so I would recommend changing it. So I made mine name 1 and name 2, but you can call it thing 1 and thing 2 if you want, for example. But you get a lot of flexibility here. So if you remember from from EAM, that was pretty much baked in. Finkel just made sure you got a .h1 or a .h2. That was the only control you had, and you didn't even have control there. Here you have complete control. So you can say like, this is for my ARM study, and this is for this other person's study. And then it's really easy to be able to parse those files, send them off to the appropriate people, and not have to kind of parse the little parts of the string that's a little different. And then we have the output control, and that is exactly what it sounds like. It's how frequent do I want this output, and at what frequency, and that follows the seam convention. So you'll see n months, n hours. Now, note, you don't change this with seam. We just chose the seam convention because people are familiar with changing rest n or stop n to n hours and months. And so we wanted to keep that consistency so that it was easy to parse. So you can do n secs and and steps and minutes, etc. And that'll be exactly what you expect it to be. But you just specify that explicitly here. Does that all make sense? Yes.
So one thing I liked with the older version is, like, let's say you had a whole bunch of averaged fields, but you wanted one max field. You could just put colon.
Yes. So you're saying here you could do like Q:I, and then the rest could be,
So that's no longer.
That is no, so that capability is gone. Now you have to have a whole new file, which, yeah, that was an exchange we had to make in order to go to this new system. Yeah.
It's worth to point out that a lot of things in EAMxx can be added if there's strong desire of features to be added, but we went for what made implementation easier.
Yeah. So I guess, yeah, Luca makes a good point that if there was a really strong desire for that, we could go into the output interface and change that around a bit. But yeah, we went for the simplest to start with because we were also testing and debugging. And yeah.
Adding some max to an average file will probably be doable because they're both like on a window, right? In both cases, you have a window of interest and you pick one value for the whole window. Mixing instant and average, for instance, it will be a mess. Allow that.
Yeah. Well, yeah, it's something we can think about. I'll just note this is a perfect time to say that EAMxx is also still always undergoing development. And so we are, exploring ways that we can improve the development. If there's a strong need for a particular feature, then that's something that we can think about, right? I'll also actually note, because I forgot to mention at the very beginning, you might notice that there are 3 in all of these. There's there's 3 things being listed here. And that's because in the old version in EAM, there's a default output that you always get, right? The only way to turn it off was to do something crazy like this, where you say, like, give it to me every 1,000 months, and then you wouldn't get it. But it was going to try to make it at least. We no longer have default output in EAMxx. If you don't specify output, you get nothing. One of the big reasons why we did that is from memory's perspective. It's painful if you get just a bunch of output you do not want for a run that's running at 3 kilometers and producing terabytes of data. So we did not want to put users in a position where they had to remember to somehow get rid of a default set of output because they actually didn't want it and they were running out of memory. And so here we really wanted to empower the users to be very much in control of what output they get and how. Yeah? Cool. Yes?
So yeah, I need one output YAML file per output.yaml.
Per stream.
Per every file, but how do I name these YAML files?
Oh, you can name them whatever you want. So going back to my So I named it my first output YAML file, my second output YAML.
Where is that at?
So this is just my example. You guys have this one, so I'll do this. We're actually going to do an exercise. So actually, maybe better is to go ahead and do the exercise. I think it will answer your question, Rob.
Have you got just the exercise?
Okay, so we've already seen this, right? So the run script copied this output file. Actually, I copied it to the case script. So I know it's in the data, but I would like you to be looking at the one in the case scripts directory. Now, they're the same because they've been copied, but it's important. That's a distinction that's very important. Okay, so if we look here in case scripts, there's this output YAML file.
Aaron, I would not use plus equal for that thing because every time a build NML runs, it's going to have the same output.
Yeah, maybe I will, and then we can show it as a user error. Okay, so you have this output YAML file. It's quite robust, but we can see all of those fields. By the way, they don't have to go in this order. It's a parameter list. They will be found. So if this file name was down here, that would be fine. You don't want to embed them though, so you wouldn't want to put it below fields. So you see I have an averaging type for this one. I want one snapshot per file. The file name prefix, I'm going to have it call it tutorial output EAMxx, and I have tons of fields in there. You don't need to, but I'm basically getting everything but the kitchen sink. And then down here at output control, I'm going to get it every day with a frequency of 1. So anybody who actually successfully ran a case, you probably have output in your run directory that has this prefix. And I think the run is for how many days now, sir? Did you set the date? 6 days. So because it's 1 file per day, you should have 6 files representing the 6 days of data. That make sense? So what I want you to do for the, I have to do that. What I want you to do for the exercise is I want us to copy that file and give another file, like the same file, but give it a unique name. So I'm going to say my new output.yaml, let's say. So we'll just copy it for now, instead of creating one from whole cloth. And then let's go ahead and open my new output YAML file. So what you have, you don't have to do exactly what I'm going to do, but I'm going to make some changes here. So now I'm actually interested in instantaneous input or output. And this is really important. This is the one thing I do want you to do. Please change the file name prefix. This is that PSA about you don't have to call it, you can call it literally whatever you want. I'm just going to call it that for simplicity. But then down here, you can decide to do the same variables. And here, Rob, you can see you asked about putting comments. So you can see that here I'm commenting 3D variables, 2D variables. So you can put whatever comments you want. I'm going to go ahead and make this one just be temperature. I'm going to get rid of everything. But I'm also going to have it happen every step. And there should be 48 steps in a day. So I'm going to go ahead and just have 48 snapshots per step, per file.
That's on every 48 snapshot.
Oh, you're right. Sorry. I need to go up here. Thanks. So I need to make max snapshots per file. That's right, 48.
There are also power user ways to specify, put every snapshot from this month in the same file.
Yes.
We can go over those later, or just the implementation specify.
So to kind of explain what that is, so it's kind of a pain to do like weekly output, but wanted also a 1 file per month, right? Because some files have like more than 1 week or maybe daily output's better. Daily output, but I want a January file and a February file. You can't really do that because you have to specify 31 days for the first file and 28 days for the second file. So you can actually just specify, I want you to open a new file every time I change month, for example. And then you'll get exactly that. So you'll have the first file will have 31 snapshots in it, and the second file will have 28. So that's a power user functionality. So there's actually a lot more to these options, but of course, for simplicity, we're going to stick with the simple ones now, and then we can expand.
That is a very nice feature because it's really frustrating.
And that's also going to change the name of the file. Like in this case, the name of the file will contain the full timestamp of the first snapshot that it's written. But if you ask for a month, it will only contain like 2010-01. That's it.
Basically,
without the snapshot.
Basically, about the H0.
Right. depending on the type of storage you choose, it will change slightly the name to make, because this, it looks easier to parse. You don't need to see the second of the day. That's not first option, it seems.
Did everybody get this far? We good?
We can just show later, like.
Oh, yeah, we can.
And another thing I want to mention for power users, you can, in the frequency of control, you can use scene variables to control it. You can use like dollar, braces, stop. Yeah, something like that. And then,
Not M or N.
which is why, and I think we didn't mention earlier, this file should not, the file you create should not be in the run/data.
I was going to get to that.
Yeah, okay.
But it's a good point. No, Luca makes. It's very important. So actually, maybe I'll just say that now because we brought it up. So the reason why I wanted you to do all of this editing I'm having you do in the case scripts directory is because everything in run data gets overwritten. So you can't manually copy a file to run data and point to it. You need to point to the file somewhere, and then it will get copied to your run data directory. Does that make sense?
That is the proper scene way too.
Exactly.
Everything about the case gets edited in the case dir.
Yes.
But it's kind of tempting to just say, oh, actually, I want it like instant. Let me go and run data and change it to instant, and then it will still be average. How come?
Yeah.
Because it's regenerated. Build that now.
Another benefit of that is if you are working in a group, you can, these files do not need to also reside in the case scripts directory. They can be anywhere. You just point to them in what we're about to do, the step we're about to do, you just point to them wherever they are, and that is where they'll be copied from. So that allows you then to have maybe a database of output files that don't have to be keep copying everywhere. They can just reside somewhere in a common directory, and then people can point to those, and then they'll get pulled. That's all.
And that's good.
Rob doesn't like this idea, but it's a possibility.
But it's also convenient if you have a map file that you need to, because you want to force an output, and then the map file contains, you don't want a full path for that machine. And again, it's just the same file can be shared and used on different machines because it has XML variables.
The XML variables allow you, yeah, so these are two distinct things. One is just what I'm saying, where you copy and paste these if you have your own. What Luca's pointing out again is that there's another functionality which we're not going into here, but there's another thing you can do with output. You can online remap. So we're doing any 30, but let's say you only want any 4 output. If you point to a remap file that's been generated, you can specify you want it remapped. Then it will apply that remap online, and the output you get will be on the grid that you asked for. This also allows you to do regional output or just specify single columns. It basically fits in all of that. So it doesn't actually have to be a full globe remap. It literally just needs to look at a file in the typical remap format and apply weights as appropriate, and then it will just get you output in that regard. So what Luca's pointing to again is that using scene variables, that map file may very well be stored in bin local root, where we put a lot of our mapping files. So in your output.yaml file, you can specify that flag, the scene variable flag, and know that even if you take this file and copy it to another machine, you'll likely get the exact same map file. You don't have to go and look for the hard path. So it's really convenient for that as well. So what we're going to do now is first, we're going to use our wonderful atmosphere query command, and we're going to atmosphere query output YAML files. Sorry that this, I'm going to clear this actually, and then we'll do that again. And
One more time, because
yeah, what's going on with that? So you can see, right? Scorpio output YAML files is one of the things in our runtime parameter list, and it's just got / output file, right? The / is going to tell it in the case scripts directory. Again, this could be a path, but that is the only. But don't do it because Rob says we shouldn't. But output file there, right? Is this output file that we just like looked at and copied? So what we want to do is add a new output file to this string, this list, so that we'll get more than one. So the way you can do that, that Luca wants me to show you, you shouldn't necessarily do, but we're going to do anyway. In the scripts is good, but doing it on the fly could be tricky, is you can just do atmosphere change and plus equal as an appending command. So if you do atmosphere change, or no, sorry, not plus equal there, but output YAML files plus equals says I want to add something to this list. And that I'm going to add is going to be /, I don't remember what I called it.
Instant.
Oh, instant, yeah. Instant.
my new output or something.
Oh, that's right.
Oh,
List it really quick, yeah. Okay.
And whatever you named yours, you are welcome to use that. If we want to be really careful, we can now make sure that everything happened the way we wanted it to. And sure enough, oh, I see I even messed up. This shouldn't be my new output file, but that'll still work. I forgot the /. Let's find out. Okay, so now we have a list of files that it's going to do. So if I do case.setup again, see if it's actually going to throw in there to me. I think it'll work actually. And now if I look in my run data directory, I can see my new output YAML file now there exists. Yeah. And actually, because we use that seam for frequency, sure enough, the frequency is stop n equals 5. And so my frequency was 5. So I use that seam variable, and you can see that it's not the seam variable here. It's the actual, it queried it from seam and replaced that value for me.
What did you run to get the new YAML and run data?
Case.setup.
Anything that runs build an ML.
Yeah.
Preview name.
Cases should be equal.
Oh, so preview names is another way. But I think if we run it again, it's going to try twice, right?
Yeah, so my suggestion is if you want to change the YAML files, start with, output YAML files equal name of the first one. So that's going to overwrite whatever that list was. And then for the second and third, you can use +e. But make sure that if you run it again.
But it shouldn't be a problem because it'll copy it twice, right? But what Luca's trying to say is that plus equals is a command that will get run. And so if you keep running it, you're just going to keep doing plus equals attached to it. So you'll get an ever longer string of options. And that's not necessarily safe. And so you don't have to use plus equals.
It will crash at runtime.
Because it will be.
Oh, because it will look for them. Yeah.
Two strings will try to write on the same.
That's right.
Hey, already defined unlimited dimension. What are you doing?
So it will get through the build NML. That's right. But it won't.
We have to add a fix for that build NML.
Yeah.
It didn't.
See, I didn't think it would, but you were very adamant it would. Oh, well. So we're going to have a little debate about this. But the other way to do this properly, which is, I think, the safer way, it's true, would be to atmosphere change output YAML files equals. If you did the atmosphere query first, you would have already seen this one. So you can just do that and then do like my.
Your script already had that. You can do like output files equal the first one and then issue it again plus equal the second. That's fine.
So if I do it like that, that is literally just making the list much safer. It's control. I'm not using sort of this appending step. I'll also note that if you are doing appending and you hit an error, that appending kind of is embedded in the call sequence. And so that can also get you in trouble.
I think we added some
protections for that.
the documentation, some like example about things that could go wrong.
Yes, at the end of the part 2, we're going to talk about things that can go wrong. So we'll go into a lot more detail about that. So now that you've done that and you've rerun it, hopefully now you can see that you have two output files. I'm going to check on time here. So we're coming close to lunch. That's good. Okay, before I go any further, that's finishing up just talking about basic output control. And again, we're here as resources for even more in-depth questions. And of course, there's, I noted in the very beginning, and now you have the slides, there's a link to the EAMxx docs, and those actually have like a whole section on output, and it gives you all of the different output parameters you can specify and what they represent. So you can do a deep dive just going through the docs if that's something you're interested in. But are there any questions on output before I proceed? Yeah.
It's not about output, it's about atmosphere change. Do you have any record, just like a test status to record any atmosphere change you did?
Oh, yes. So Shuei's asking if there's any way we can even know what the changes are. And Jim's going to have to correct me if I get the XML command incorrect. But it's XML query. I always have to use P. I think it's still Scream is the name, or is it EAMxx?
It's still through.
Yeah, I'll actually note that too. But it's gonna take a while, but there is a screen buffer.
ATM change buffer.
So
Underscore ATM change underscore buffer.
it's all caps though, right?
Yes.
That go into replay.
No, it's scream underscore ATM change one word. Yeah, it should be that.
There you go.
There you go. That tells you all the changes that are issued.
And then go into replay.
Go into replay.
Replay.sh. Yeah, none of these things are appearing in case status yet. They should.
That's a question for Jim. It's a good thing he's here.
If you open it.
Yeah.
So one quick clarification, you might wonder what the heck is ATM change set? That's just like an implementation detail. We can just eliminate that string from easily when you parse. It's just used to replay the changes and know where one change ends and the next starts. Just yeah, it's just we needed like something to clearly separate it. That was not already like something that bashed interpreted somewhere else.
So
Yeah, go for it, Ron.
So it looked like when I first created the case that there already was an output.yaml file, case scripts. Who made that?
Okay, that's a good question too. Thanks, Rob. So Rob asked, there was already an output.yaml file, and I already said there was no such thing as a default, right? So where'd that come from? So we were a little sneaky. That's in the run script that you guys ran. So actually, I'll go back and look at the run script because I think that's actually it's
Running ESM.
Yeah. So if we go to the run E3SM, back where you would normally see the user nameless settings, right? Where we would have like a cat EOF and it would have all that. We actually put that in the run script. That was like a detail we snuck in there just so that we wouldn't have to go back and do this. Maybe that was a bad choice. Maybe for the future tutorial, we won't be so sneaky. So yeah, if you do this run script, you'll always get this one, but that's not specifically a default. EAMxx is not doing that. This run script is doing that. So if you delete this, you won't get one to start with.
We added that just to keep the comfort of people who don't E3SM.
Yeah.
That's how you create Apple files. But for these files, you can just create them anywhere. Yeah. Point to them.
Yeah, we debated about just making this file somewhere, saving it, and having you guys copy it. But then we also realized that one of the tools we can give you from this tutorial is this run script that you then are comfortable adjusting because it's a run script that's familiar. And this is a familiar way to generate at least one runtime option.
It's also the only way to make everything in a single run script without the need of having your stuff.
Yeah.
But in a regular production setting,
I think it's better this way personally. Yeah, everything kind of self-documented. This is what I did. These are the output fields I made.
Yeah.
Files get too long. I lose track of what's happening now.
But this file is already 626 lines, so just go to town.
Since I never use the run script, I can see I will have a output YAML file like sitting in my top level home directory on every machine, and I will just copy that into my case pair.
Yeah, that's exactly right. So whatever, if you
not to write from scratch.
Actually, the whole point was not to write it from scratch. We wanted to get away from that. We wanted people to have output YAML files they've created for their purposes that they could then copy into their kscripts directory and be comfortable with without having to write all that out. So that's exactly the workflow. That's the workflow I use, for example, because I use like create new case, create all of that. So I don't use the full run script. So if that's something you do and you bake your own in-house run script, you could add something like just copy my output YAML file.
That's what we've done for all production in EAMxx.
Yeah.
We just put this there with a nostalgic comfort of it.
Yeah.
And Aaron, yeah, it's very useful to show this YAML file for output. Yeah, so specify whatever needed. And my question is there a master field list somewhere in a document or?
That is on the develop. There's an issue for that. We want to, yes, because like in EAM's output, it prints like all 10,000 variables you could potentially choose. We want to do something like that, but a little bit more. We do have it. So I'll get to that. We do have one way you can do it, which is the DAG.
No, we can dump a dictionary.
Oh, we do. That's right. Oh, yeah.
But you have to run the code to save this YAML file that tells you every single.
That's right.
So the thing is, the
Okay, so this is the tedious part of the output. The huge part of the output in EAMxx is that we have all sorts of fancy online diagnostics that we do. Yeah. And these are hard. Yeah, because they are arbitrary.
Okay, yeah. So to get to Nasser's point, so yes, coming back, just ignore my previous answer because I'm out of the loop, I guess. No, because I can't remember everything. But Luca pointed out, yes, we do have the ability to dump all the fields you could ask for output to a YAML file, but you have to run through the code first, just like you would for EAM, where it dumps it to the log, and then you could go back and add fields as you wanted for that. But what Nasser's pointing out is another aspect of EAMxx is that certain diagnostics are abstracted. So for example, if you want any variable at a certain layer height, let's say you want at the 300 meter height, we have a diagnostic which is at X meter height. And so that really can't be printed as a YAML file because it doesn't make any sense. But it is something you could do. You could say tmid at 300 meters, and that'll actually that will interpolate the temperature to a 300 meter layer and then output that as a 2D variable. And so those are harder to just print out. So we are working, I think we do have, at least we have a Confluence page where those are listed.
We have it in the official docs built like it.
And so we have it in the official docs as well. What those are. Actually, I think this output file that we have, I can open that too. This one has some of that stuff.
Yeah, those are also.
So you see all these 2D variables here? So this is the, the shortwave flux at the model's top. Or actually, no, that's not the one I want to do. But like here, potential temperature. That's just potential temperature. So if you ask for potential temperature, you'll get the full 3D potential temperature. But here you're specifying at 700 hectopascals. That will be interpolated on the 700 hectopascals and then printed out as a 2D variable. So we have this abstract diagnostic, which is at X hectopascals done. It's actually you can do millibars in pascals as well. It will interpret, but that's an example of these sort of diagnostics that don't have like an explicit name because they're not just one thing. They're just this capability. Yeah, Charlie.
Could you just briefly say what other diagnostics you have besides at some vertical level?
There's
liquid water path is done.
But again, as there's a pressing desire for them, there's no reason why they can't be added. So diagnostics is actually an ongoing thing that we're adding to.
Just to answer that, we have a subset of that. We output daily is, which is at
one band.
Yeah, just one band. But you can expand that to output at any band you want. We have column integration, we have integration, all sorts of things.
Horizontal, you can get a single point for the whole globe if you want horizontally averaged.
We will try to showcase these things.
Yeah.
We also welcome.
Yeah, we welcome questions or like suggestions. Yeah.
So for this kind of for any of the 3D fields, so you will see.
Yeah. Any 3D field, if you do underscore at underscore something pascals, meters, it's actually meters, pascals, hectopascals, or millibars. And level. Oh yeah, and level. So you can see like level 3. It'll take that 3D variable and slice it according to those circumstances.
Yeah, we cannot do that for actopause.
We don't have.
No, we don't have atropopause for that.
Yeah.
But that could be.
The diagnostic actopause level and then
Yeah, for sure. There's a lot of flexibility built into these. They're all independent. They're all independent like diagnostic pieces of code. So you could build one, add it to the library, and that one is now available.
We have cloud.
We have a cloud top, that's true.
And cloud-based.
And if I could open the docs file, I'd show you. But you guys can open the docs file as an exercise, at your leisure. Okay, so I'm going to move on just in the interest of time because we're okay actually. We have about 50 minutes till lunchtime. But the next topic is just sort of like more ways to run EAMxx. So is everybody familiar with doubly periodic? I assume single column model is something we're familiar with. So double periodic is similar to single column model in the sense that it is like an idealized setup, but Doubly periodic has a periodic domain that you specify, and then you run in a full full domain that has a certain width and depth and everything. So doubly periodic configuration allows you to run in these small domains, or just a super high resolution because you're running on such a small domain, to do things like experiment with the physics or look at what happens with certain properties. It is something that was put together by Peter Bogenschutz, and if you're interested in more details about doubly periodic, I highly recommend seeing his talk. I think it's tomorrow at the EAMxx breakout. He's going to give an actual talk about DPXX, so you can learn more about how it's used. But what I wanted to talk about here is just how do you fire up DPXX for running yourself here with EAMxx as part of the tutorial. So I don't know if Conrad, do you want to describe this slide? Did you put it together, or if you'd like me to just go through it? All right. So it's actually, the long story is it's pretty simple. It's about as simple as everything we've done so far. DPXX, there is a library of scripts that Peter Bogenschutz curates, so it's very much up to date. He makes sure that they are working always with the latest version. That you can find at this DP resource page, so you can click on the link that's in the slide to go there. And so that resource page will send you to a generic run script for your own domain, and then a whole library of cases of observational campaigns where there's specific setups for that campaign that you can do DPXX runs for. But really, full picture, you essentially just run that script just like you would run the script that we just did, and it will run EAMxx just like you would expect, but in that doubly periodic configuration and provide output for you. And then basically, what you've learned today gives you the capability to go into that script and kind of understand what's going on, and then make adjustments as you need for your specific use case if you want to build on what Peter's already created. So here are just some important Namelist options. All of the doubly periodic configurations specific to DP are under IOP options. And IOP stands for
Intensive
observation period. So that's the formal name. So if you want to go and also look at those options, you can do that just by looking at what is available in the IOP options. Now, note that I don't think this will show up in that script until you build with IOP turned on, at which point it will be generated and you can atmosphere query it, right?
No, IOP is a one-time. It's a process.
No, it's a process, but if you don't specify it's a process you want to use, does it get populated in the nameless file? I don't think so.
I don't think so, but you can easily just add it.
Yes. I just wanted to be, so if I atmosphere query IOP, actually, I guess any, there's nothing there. So if I add it as a process, so atmosphere change, where should I add it? To?
Yeah, no. I think we did the very beginning. Or it doesn't matter.
I'm just going to add it to the end of physics.
Yeah. Doesn't matter.
What is its atmosphere?
I'll give you @cross_list.
And I'm going to
query it first, make sure it's right.
Should I do back arrow make then?
Yeah, column pattern. What's this?
Column what?
Atom underscore box underscore special.
I'm going to do this one and just add IOP plus equals IOP. Is IOP for? It's
also do plus.
Yeah, it's probably IOP underscore.
It's going to yell at me. Nope.
Oh, you have to reset. I was going to change that.
Okay. Let's see if this works. And then we'll atmosphere query any IOP. Oh, IOP forcing. There we go. So IOP forcing is the name of the process. That is all handled in the run scripts that Peter Bogenschutz has created. But I want to just note that that name list doesn't have everything that is ever possible. The name list that's in your kscripts directory is based on the configuration you've created. So if you do need to have access to a process or you want to see what the options are for that process, the the case actually has to know that you want to use that process. By default, with our current comp set, you'll get pretty much everything, but like IOP forcing is a specific use case. So it's not by default added as a process that you want to run. So you'd have to add it like we just did. And now you can see it exists. And now I can start making changes to it.
These are the only IOP options. These are the options for the forcing process. The other thing is the IOP options, which is, maybe this is not the best way. No, it's not a process. So it's just a separate section.
To query. I see what you're saying.
There's like 2 places that there are IOP options.
It's gonna be there.
So something like that. But again, if you are going to be using DPXX, they're like the resources for running DPXX are really good on that DP resources link that's on this slide. So I highly recommend going to that. There could be a whole tutorial on using DPXX if we wanted to be like a whole section of the tutorial. I think it's just really important for this group to understand that this is one of the capabilities available to you and give you the tools to hunt down exactly the specifics you need if you're going to be doing that. It can also be an exercise at the end if you want to play around with DPXX. Okay, so the last section of this part is going to focus on our unit test suite. So another big aspect of EAMxx is we have a pretty robust set of unit tests, like on the order of 350 plus or something.
All the OMP multiples of 560.
So we have a lot of unit tests. This is a big part of EAMxx development. We wanted to enforce that whenever new functionality was put into the code, that we were also adding unit tests. This is just a software best practices. And it really has helped us debug very quickly. So, new development, if it breaks the code, the unit tests really allow us to like zoom in on a specific part of the code that's broken because those unit tests will fail. So it's been really useful. And these unit tests can be somewhat complicated, but they can also be incredibly simple, like 4 lines of code. We're just like checking the 2 + 2 = 4. If that breaks, then something's terribly wrong, right? So what we're going to do in this part is actually just run those unit test suite. And so if you're developing in EAMxx, just like you would run the E3SM developer suite before you would submit the PR and verify that, yeah, my code's not going to break E3SM master, this is something you would do for EAMxx. You would run the full test suite and make sure that it doesn't break any of our unit tests. So hopefully you were all able to get this line, because typing it out could be a little bit cumbersome. But you actually don't really need this part. Or maybe you do. No, I think you do actually, because I don't think it will run from the login node. So you're going to first have to get an interactive node. Yeah, Jim?
Yeah, I just wanted to ask, you mentioned that we're transitioning our name.
Oh, yes. Okay. Yes.
Yeah, I just on the top of your slide here, test all stream.
Oh, now it's test all EAMxx, yeah. So this is like hot off the presses. We would hope to get this done before the tutorial, but it is kind of a big, it was a big change. But Jim has been working on this and it's slowly transitioning. So just as an aside, so when we started doing all of our development, the name of the project was Scream. So we use Scream almost everywhere, just like those of you who are familiar with the Atmosphere code, the EAM code see CAM everywhere. It's just kind of like a name that's fit. But now the code itself is really EAMxx, and Scream is the configuration. That's the set of physics that we're running, the simple cloud resolving E3SM atmosphere model. So we're really, when we say Scream, what we're really talking about is running at high resolution at the cloud resolving scales. And we wanted to make a distinction with that to running just the atmosphere component at any resolution with any set of physics. And so EAMxx is the actual atmosphere component. But now we have to go back through the code and change any location where we've used the word Scream to EAMxx. We don't have to, but we're doing that because we want, for legacy purposes, there not to be this kind of confusion. So we want, if you see Scream, that you recognize that is for sure for this particular configuration. And so Jim has started doing this. The first step has changed sort of the outward facing names from Scream to EAMxx. So there's actually a typo here, because in the second line, I'm using, oh no, it's not a typo, it's test all EAMxx.
First bullet. There you go.
Oh yeah, so this bullet, this is an old bullet and that's the new bullet. So it should be test all EAMxx because we've changed from screen to EAMxx. But that's semantics. Yes. So you should run. Oh yes, good point. So first you should get the interactive node. So I'm going to start that up first because it won't run from the host node. You want to go, so this ./components, this is from the E3SM root. So if you go to wherever you stored your E3SM code, so for example, for me, that's going to be in just /code for my home directory. This will then, issue the script, which is in components EAMxx scripts test all screen. Now, this is the most basic line here. You're welcome to run it. This will build all of the tests inside your E3SM repo. What's that? And run them. But the distinction I want to make is that it builds them inside your E3SM because there's nowhere else to build them. That can be annoying if you're doing development because then if you add all, you've now added a bunch of tests to your branch and that's not what you want. So there is an option to do -w and specify a directory. So that's
Run the -help first so that we can.
Oh yeah, I can do that. Oops. Doesn't like me. Oh yeah. Let's make this bigger. Up a little bit. A lot of options. So you don't have to use them all, but they all have a particular use. For example, so like if you want to set a baseline directory, for example, or you want to generate baselines, these are things you would want to do for testing. There are some requirements. Machine is required, so you have to specify the machine that you're going to use. And so the line that I have in the slide does specify the machine. There are more than one set of tests, and that has to do with the compile time options. So there's like a debug version, a single precision debug, debug with pack size 1. We can talk about pack size in part 2, but with floating point exceptions on, there's a release version, debug coverage, quite a lot of versions. So if you just don't specify -t, it runs them all, which could take a while. But if you really want to make sure that you haven't, it runs 4. It runs those first 4.
Just have to run floating point exception.
Because it's not necessary. Yeah. So it will run 3 or 4, but if you specify the -t, that'll give you at least 1. So that's totally a flavor of yours, what you are actually running the tests for, if you want to specify that. But here, this is that -w I was talking about, or -- work directory. This just allows you to store the tests in a separate directory, maybe in your scratch space, for example. I'm not going to go through them all, but suffice to say, you can read what those options do and then use them. Is there any other option that you guys use specifically that you think we can highlight?
You might want to do it because there's no baseline comparison unless you request it. If you don't do -b, it only runs internal unit tests. But if you then add -b and then the baseline directory, assuming that there are baselines there, otherwise the error out, it just goes looking and does also comparison, bit for bit comparison against it.
Yes.
And on our supported machine, -b and then the keyword auto, all uppercase, will pick the default baseline directory for that machine if we support it.
Yes, and we have, so all of our supported machines, we run these tests nightly. So we have baselines that are generated nightly. So if you want to make sure that your change is not bit for bit changing, so non-bit for bit, that's something you can do by comparing against the up-to-date baselines.
You can inject, you can use the -c option. Yes, you can inject options.
Oh, yes. So if we have different compilers, compiler options, yeah, CMake options.
Is it on the list? Yeah,
it's right here. No, that's the compiler. -c.
Custom CMake options.
So these are all these options exist because we've at one point or another needed them. So they are pretty useful, but it really all depends on what you're doing with it. So if we go ahead and just run that command, I'll let it just kind of run in the background. And I'll go ahead and let it do its thing without, or actually I can just do this and just put in my scratch space.
Yeah.
Oh yeah, that's true. Debug's a little longer.
Simple precision does not build dynamics and radiation. They're not built for simple precision, but at least. Another thing I do sometimes is dash config only. And then I hop in the build directory and only build the tests that I want to run.
Yeah, so config.
Yeah, that's a really good point. Building the code, it requires kind of a convoluted CMake command. So it can be, a little bit, formulates this out. So yeah, I often do, you can config only, or you can run test EAMxx, and it's full see it in like the first 2 seconds, and one of the first things that prints just the CMake command. So you just grab that and you just put it in the directory.
So here's that. So to repeat what Jim was saying. So what I'm doing now is building the code and running the tests, but you may just want to configure the build and then do your own building or build just the test you're interested in. Because as I said, we have hundreds of tests, right? So you may actually really only want to build the input output tests, for example, and you don't want to waste time waiting for everything to build and then potentially run. So config only is an option that you can use for that. And what Jim was pointing out, when it prints to screen, so it's going to give us an update. It's going to be building here. I think this is configuring, but this is the CMake command. So you could literally just take this command, copy and paste it, and run it as a CMake command, right? Well, not
the CMake command equal.
Yeah.
Yeah, you want to copy everything that's within the quotes. So it's a little bit.
There you go.
There you go. So you copy that whole, and then you have to find it close to the quote. There you go. So if you copy that, you put CMake in front of it, and then at the end you have to put the path to EAMxx. Then just test development. Work there.
You want to preload the correct environment you build things by hand. Switch there's a script that allows you to do that for the current machine.
It's the first line.
Oh, it's the first line.
You see, there's one where the bracket that would be the
yeah, whatever it's coming out of the top. There's no value passed or blah blah blah. So the line after that is what sets up the environment.
So the output will appear. If you don't have that -w argument, the output at all, it's written to where we execute.
It gets written to components EAMxx/ctest build. So you could just purge that directory too.
Should maybe add that to the ones.
I always add it to my local.
We could do that. But sorry, you were saying that yeah, you can load the environment as well.
It's the third line after you're looking at it. Go up.
Oh, here.
Oh, all of that. If you copy paste that in your bash, that will load all the modules that you need. Then build them.
Yeah. So the wrapper test level screen is really great if you just want to check and see if your tests are building and running as you would expect from your code. But as you get into more intense development, tools like being able to just build exactly what you want or set your environment or consistently go in and keep building the code is really useful. I'll also note that once this is all done, there will be now a directory with all of the tests in it. And if I make a change, I can go there and just issue make dash. Well, you can just issue make, but that's serial. So if you have access to cores, you can do make -J and then some number of cores. So if you're on allocation node like I am, you can make that like as many cores are on the node. And what that will do is recompile all of the unit tests. So you can make a change and then recompile. So if you hit a build fail, you can try to fix that bug. Just go right into the directory, make -J whatever, and then see if that fixed the bug. And so you don't have to go through the cumbersome, like rebuild from scratch everything just to get to that error and then have to go back again. So it does also improve sort of production time when it comes to dev, because you can just very rapidly build tests. They build, if you're building just a single test, they'll build in like seconds. And it'll either throw a build error for you, or it'll get through and then you can run the test and see if everything looked the way you want it to.
So what exactly are those dots? I know it says like it up, but
It's what you would see with E3SM log the build, all these lines. It's basically that.
So these are all warnings that it hit. These are all just lines. And what you're hoping is you never see one of these guys, because that means that failure is imminent.
haven't run SPA.
It might stick there and then fail a little bit later, but you know for a fact things aren't, something went wrong.
Is there a verbose option? So instead of dots, I actually give the judge.
Is there a verbose option, Jim? A verbose option?
So instead of dots, I get the actual question. And so, yeah, it's just CMake basically hiding all that output. Sorry, that's CMake. So yeah, if you want verbose, I would just build it your own.
So really it would be productive to show them that think only and then the new directory.
Do it.
Yeah, just answer this. Zero yeah.
Okay.
We will config only, that config only. And then it will just wait for it to
Well, I'm gonna preload, but I have to do this.
Yeah, just copy that.
I'll copy that for now. This will also give you a verse, but you can now see your verbose output, Rob, when we're done with this.
Or when you do make XJ thing.
Yeah. So it's still going to configure it though, right?
Yeah. I mean, so configuring actually makes a whole directory with a lot of files and all sorts of complicated. We will see, we'll go to that directory.
And note that this does not have to be called anywhere specifically. This line that we're pointing out here, this eval, is literally just like setting your environment. So you can set that anywhere. You can even make an alias for this if you want for PM or something like that. So
Yeah, we have a shortcut tool to develop an environment screen for EAMxx. Go under scripts.
Yeah.
There's like a
stream environment command.
Yeah.
So in the if you go to the same scripts directory where the test call scream script is, so in here, scripts, there's also something scream, which is it EAMxx yet? So I say EAMxx-env command. If you execute that and then pass the machine compiler you're on, so PM GPU, for example, it will also just spit out. So you can copy and paste it.
Could you elaborate on where the output from these tests is going and what the output looks like?
That's what we're gonna.
Yeah, I'll do that. So to see what the output looks like, we'll go ahead and do that when this is done configuring so we can see. But it's so the directory that you've specified, so the Scratch directory or whatever you specified, everything is being built and put into there. The code structure, if you were to navigate there, looks like the EAMxx code structure, not E3SM code structure, like after component /EAMxx. So there's a /source directory /physics, /source physics. But if you go into those directories, you'll only see tests and whatever the support files are have been created. And so if you navigate to anywhere that had any subdirectory where tests have been created, then you'll see the executable for those tests and you can run them manually. Okay, cool. So it worked. I'm going to just go ahead and get my thing all set up here.
Aaron, one thing, when you run tests manually, be careful because running the executable may not be enough because the test might expect some inputs. So one way to do it could be run C test and then.
Why don't we do an example of that? I'll go and do.
Like radiation, for instance, expects some input file, like baseline test, or nudging, I think, expects some input files. Model restart expects some input files.
So you can see here the build directory, right? So if I go to that build directory, there's all the CMake files, and you can see that I've got my, /test /source. So I could just go to source physics P3 tests. There's actually a subdirectory tests, for example. And there's tests there, but you see there's nothing made there yet because we just did the config only version. So I can issue make-j, what's a good number?
128.
128, just go to town. Yeah, so the -j just does it in parallel. So the more resources you can throw at the build, the faster it will be. This is, that's your output, Rob, by the way, it's very pretty. I'll also note for those of you who haven't done like CMake stuff or like make like this before, if I issue it again, it won't be this ugly again. CMake will actually only rebuild anything that's changed or any code that's changed or is dependent on something that's changed. And so
it's basic make that
Yeah.
does that.
So make will do that.
Even our tools.
So it's only this one time because now it's literally building everything from scratch. We're going to get a lot of output. But if I were to do it again, it would just show me very quickly that everything is exactly as it should be and we're good to go.
Yeah, so if you're debugging something, this feature is convenient because you do a lot of, rather than rerun tests on the screen that will rebuild it from scratch, you just go in the folder and do one change in the source code, it's just maybe a handful of files to rebuild.
And it will show, and then you get the error message out right away too. It'll point it, you'll actually get to see it build in real time, basically. And occasionally the error makes sense, and then you can say, oh, I know that if one classic one for C++ is it will tell you one line doesn't seem to work because it's looking for a semicolon after the thing. And you'll say, but the semicolon is in that line. I'm so confused. And it'll be because the line before doesn't have a semicolon, and somehow that's how it catches it. So those are like, you'll get good at these.
You can also like see the warnings if you build by hand, which our system doesn't consider failures, but some warnings, I've seen some warnings that should actually be errors in my mind. But for some reason, CUDA says it's just a warning. So if you build manually and you see a warning in the code that you added, don't ignore it.
Yeah.
Even if it's just unused variable, the problem is that when you have a ton of warning, then it becomes noise and you ignore it. And there can be warnings that are actually.
Actually, I'll take a moment, I guess, since we're waiting for this to build.
See, that's something we should have even.
Something we do want to clean up the warnings.
I think so.
Yeah, when home it's like 25 pixel warnings.
Yeah.
It's easy to, if there's too many warnings, we learn to ignore the warnings because and that's the problem, right? Is that we can get pretty messy code.
Yeah, I mean, the mixing return statement is bad, but it happened to be okay because there's no way that we can actually reach the end of the function. I know what function is, but if something changes in the implementation of that function, that could turn into like a bad warning.
So while this is building, does anybody have any questions about all this before I can show us a test in real time running? Has everybody been able to run this command line and just kind of get something similar? Maybe not this exactly, but those little dots and stars.
One thing I mentioned with C-test, you can run a bunch of tests based on a piece of the name. So you can do dash capital R, and it grabs for any test that has the string you provide in the name. So that's helpful if you're like, I know it's some test, I don't know which folder it is, but just go run it. It has this in the name. Another thing is you can attach labels to test, which we do. So you can do dash capital L P3, and all tests to which we attach the label P3 will be run. Say you fix something in P3, you don't care about running shock unit test because shocks itself. But you say, hey, run every single test that has the label P3 attached because I want to make sure my changes are still working. So that's another way to use C-test effectively.
And when you build your own tests, which is something that we'll have as an exercise after lunch, that's something you can think about. It doesn't need to have only one label. So we have some that are like P3 and have P3 and shock attached to them because there may be a couple of tests with both of those processes. And so you'd want to test that test if you change shock or P3, for example. So there's a lot of versatility also as any of the tests.
Yeah, you can attach as many labels as you want. And you can even combine them, run all the tests that have these two labels attached. And that just allows the test to only run the test that you
and it will
explain the documentation because it's CMake product was the stand, so it's blended. Yeah, keyword.
Keyword.
Yes, the documentation is quite.
So maybe it's taking a little bit for this to build. I don't think we just want to stare at me staring at a screen. Maybe if we want to wait for this to build, then we'll do one more little demonstration of a few of the features we were talking about. In that time, if folks need to go back and do any of the other exercise that we were doing and maybe need our help to walk around and work with them or just answer questions, we can maybe work just kind of on anything we want to for the next 10 minutes or however long this takes. And then I'll draw back all your guys' attention when this builds. And then we'll do a demonstration of these C-test options that Luca was referring to. Does that sound good? You can also take like a bathroom break or something or get some water if you'd like. And then I'll call you all back in for this demonstration just before lunch because we have 20 minutes to lunch. Yeah. I guess if you don't care to see the C-test stuff, then you can also just break for an early lunch. That's fine with me. I won't feel hurt and assaulted. But if you want to see a demonstration of C-test in action.
If you want to make it faster, you can just cancel this and go to one small directory.
Yes.
I can do that. That's true.
Just go to maybe.
Go in the nudging directory.
Has it been built? Oh, I can build there, right? And that's in source physics.
Physics nudging.
Okay.
Maybe that's J.
Are they supposed to all pass the tests?
Yeah.
They're supposed. Oh no.
Not all of them. We have a few that are supposed to fail.
Wait.
Okay.
Well, so wait, are there any? So on CUDA, yeah, we have 2 that fail, right? Are the 2 that fail these? Are they not run on Paramount now?
Runs on its kernel machine. It's on in a container.
It's just errors.
Did you run test full screen on your monitor?
I did, but I don't think I ran all of the tests. This is too long.
It's not failing on UCI is working.
Oh, okay. So we're missing some that's CDF stuff on Perlmutter, so there are 5.
So I'll say that we don't do our nightly test on Perlmutter for the unit tests. We do scene-based full simulations on Perlmutter. So we can run test all screen on Perlmutter, but it's not currently part of the suite that we check every day.
Well, oh yeah, these are points. I don't probably missing.
Part 2 is you guys are all going to debug our failed tests for us. So we don't have to. Just kidding.
It's a minority. It's 6 out of 130.
Okay, so we can.
We'll talk about
That last 3% is like the hardest part. It's forever. Ninja instead of make.
A replacement of make. It's better because like make it parallelize over targets, not on actual object files. While Ninja just so you can't start building a next target until it's dependencies.
So that's low. There's bottlenecks in make.
Yeah, it's long. If you have a target that is needed and it takes so long to build, downstream don't start building it. It's done. But they cannot live until that's done. But it could start building. And Ninja does it more smart.
We're almost there. We have 100%, but it hasn't released my terminal to me yet.
Yeah, it's yeah, yes. So you
It really doesn't. It's like really stuck on that 100%. It's like, there we are. Okay. So now everybody, so I've built the nudging tests. This is just one of the set of tests. So now that you see that that's been 100% built, now you can see that there are like executables that have also been created. And I think this one we would expect to fail without inputs, right?
Tests, it will fail.
So let's go ahead and run nudging tests and be like, cool, I'm going to run my nudging test. And it should fail because it didn't get its inputs. So it failed because it was looking for a file and it couldn't figure out what that file was. So what Luca was pointing out is that C-test will actually make sure that the executable is called correctly.
Even at that capital V, see the S as in, V as in,
Oh, V as in
and
maybe.
also that, when you run tests, some tests have dependencies, and so the test make sure that the test that needs to run first runs before the second one starts.
And so here, it'll run nudging data and nudging map files, which are actually required before we run nudging tests, because those things need to be created. And now it will run through the tests in the proper sequence.
Are the tests running on their own predefined grids, vertical, horizontal?
Depends on the test.
Yeah. Okay.
Yeah.
But it has nothing to do with the case stuff that we were building earlier. It's just
No.
Right.
And now, so actually, I will say that the unit tests do point. So some of the unit tests run like an in-house seam-like test where it's just atmosphere only and it runs through like all of the steps that the atmosphere would run. Those do point to an initial condition file that we have stored in a typical area that ships, like that should be on all the supported machines. But Seam is totally bypassed. There's none of these tests rely on Seam in any way.
So,
Sorry?
for when we use that, we usually specify the.
Yeah. But that's in tests, right?
Yeah, but maybe the work, it's not just saying that.
Yeah, oh yeah, it passed. You see how it passed now? So it failed when I ran it, but it passed because we used C-test. And C-test gives us also more information. It tells us like what ran, how many seconds it took and everything like that rather than just running the executable. I will say that I typically run the executable, but only in cases where I know I can run the executable because I find it just quick and fast, but you can do whatever makes sense for you. What Nasser was pointing out is that I can go to the test that we do some of the standalone stuff. Single process would probably be easy. Or just go to shock. So this is a shock test. Is the YAML file here? No, I gotta make it.
Oh, is it generating?
Ah. Thank you. Yeah. So in this test, this is going to run like a non-scene but kind of full through test. You can see that there is an input.yaml file, which looks fairly similar to the files we were looking at before. This is created, but notice here it's still using those machine config specified. So there is that one dependency. Since we are dependent on the machine config file, so this has been defined where the root directory is. So it's going to be using this unit test NE2 initial condition file that we've put into the NE2. I know it's not science at all, but it's
Just to make sure the plumbing works.
Yeah.
Like, all these mistakes, but I'm going there.
so.
Oh my gosh.
So yeah, to answer your question, Charlie, there is a dependency, but not on actually building through the Seam infrastructure in any way. But we do use some of those variables for our unit tests for things like this.
So this is in my home directory as it is in your home directory, the source code. How much space is it taking up when you run the test in your home directory? Is that something to?
It's a lot.
It's a lot. Yeah, so that's why I heavily recommend just that -W and putting it in Scratch. But again, it's up to you what makes the most sense. But it does take up a lot. So
Debug build is about 3 gigabytes. The C test wasn't C test. If you only build the debug, it's about 3 gigabytes. I remember correctly.
Oh, there it is.
Yeah. Sometimes I forget to clean up and I realize my EAMxx folder is huge.
So before we break for lunch, actually, I guess a couple of things. First off, before we break for lunch, does anybody have any questions? Is everybody all hungry? Yes.
No room left on the device for the test all screen. Has anyone got it?
Yeah.
Okay.
So if you're running it on your home directory, probably.
Yeah, because you're probably running out of storage. Yeah,
Oh, yeah.
because it's big, which is what it's
Probably wants to put the output on Scratch.
That's why I want to put the output on Scratch, if you can do it. I mean, you should do it. So just for logistics, we're going to break for lunch now. Can you be back by 1 o'clock? Wait, 1:30 maybe? So we'll come back, we'll all be back here at 1:30 to start part 2, where Nasser is going to walk us through actually adding something to the EAMxx code and running with that. You're welcome to stay here. I plan to just kind of try to get a quick lunch and come back here so I can be available for questions. And I think a few of my tutorial folks will also be here as well. So that is just the logistics. So you're free to go if you'd like. I want to add something about testing. If you get into testing and you're going to be developing your own tests, just kind of an important rule of thumb is there's no such thing as too many tests, and the tests are very flexible. So we have property tests that just test like the property of a certain process, like make sure nothing crazy happens under certain circumstances. We have basic arithmetic tests where we know that if we feed a 0 into this process, a 0 should come out the other end, and we check that. So there's like really no such thing as a test that's too simple. The idea really is to provide the developer with the most robust way to make sure they're not breaking anything, and tests are a great way to do that. And so these unit tests, is why we have hundreds of them, is some of them are really simple, but if they break, it's really clear what went wrong, and that's amazing for debugging, right?
Someone said if a function is not tested, it doesn't exist.
Cool. Well, thank you very much, everybody, for part 1 of the tutorial.